Hello everyone again, it's me Michael, and today I want to be discussing about port channel yet again, except this time we're going to be focusing on how you would do it on a layer 3 device. Because yes, on a layer 2 device it's nice to have that redundancy factor, but sometimes we also want it within our collection of routers. And so we need to be able to add IP addresses to them since they'll be focusing on that layer 3 side instead of the layer 2 side. And so that's what we'll be focusing on here. You can see that we have our notes again. So it's very similar to how port channel on the layer 2 is done, except this time instead we'll just be removing the no switch port when we're creating our port channel interface, and we'll be giving it an IP address. And then after that we'll go to our physical interfaces, turn off the no switch port, and then we'll go ahead and add them to the group so that way they can be logically synced as one. And then on the second device, we go ahead and do the exact same thing, except we give this one a different IP address since it's on the other end, and then we logically link all the physical interfaces. So we'll go ahead and start over here with our layer 3 switch. That's our switch 0. Oh, whoops. Didn't put a space. Give that a second there. There you go. Sorry for the delay there, guys. We'll go ahead and continue on. Configure terminal. There we go. So now what we'll be doing is creating that port channel. So interface port channel 1. And then we'll go ahead and do no switch port. And then we'll give this an IP address. And just to keep it simple, we'll just go ahead and do 192.168.10.1, or 10 if we really want. And then the subnet mask of 255.0. Okay. Exit out, and then we'll go to the physical interfaces. So interface range, and then we're using fast Ethernet, and it should just be 1, 2, and 3. Yep. -1-3. Then go ahead and do no switch port, and then add it to the channel group. 1 mode active. Okay. And that's it for this side. Then we'll come over here. And start configuring our second side of the switch here. Enable configure terminal. There we go. Interface port channel 1. Then no switch port. Then we'll give this an IP address. We'll just do it by .20. So 192.168.10.20. With that again /24.0. We'll exit out, and then we'll go ahead and group up the physical interfaces now. So interface range fast Ethernet 1/1 or 0/1 to 3. Okay, no switch port. Then channel group 1 mode active. Now that that is set up, we'll give it just a moment here so that the interfaces can reset. And there we go. Now we have our three interfaces here that are both logically thinking as if they're one. So this side believes it is on the IP address of 192.168.10.10, and this side sees everything on these interfaces as a .20. And we should be able to just ping that, no problem. And exit out. Ping. 20. And there we go. It was able to make its connection and send back. And we can go ahead and do that in simulation real quick, just so you can see that. As it sends. And it just goes back. And so now we're able to have all three of these interfaces on, which helps increase that throughput. So in case if something happens and we have a slowdown, we can have a stronger connection between them, right? And so when we use layer 3 port channeling, we normally use it with other routers. And so let's say that we had two more routers that were connected just above it, right? And let's say that this router ended up going down, but it was linked here, and all its traffic that was coming from here could now switch from going directly like this to into a side view here. And so this is just helping with more redundancy. By having this more throughput, it technically makes it a little bit faster sending all those files, because now instead of waiting on one file transferring between that interface, we have three that can do it at once. And so this helps with a lot of redundancy, speed, and making sure that we don't have critical failure points. So I just want to say again, thank you again for watching.